Hello students. So let us see the question number 4 from IIT-JAM 2023. So in this question, they have given you Zener diode and a normal diode connected, V junction diode connected in parallel. And they have given you V input value as 5 sine 200 pi t volts. Okay. So the peak to peak voltage of this input wave is 5 volts. Okay. And they're asking what is the waveform of output voltage. Okay, what is the waveform of output voltage? So as you can see, this diode, okay, are the reverse bias by 3-volt battery, and the reverse bias voltage for this Zener diode is given 3 volt. Okay, and if we want to conduct these diode in forward bias, so forward bias voltage for both these diode is given 0.7 volt. Okay, so 0.7 volt is the forward bias voltage for your this diode, normal diode, as well as for this Zener diode. Okay, now let us see what happens. So initially, if you see, if whenever the voltage is less than 3 volts, okay, whenever the voltage is less than 3 volts, this diode as well as this diode, both will, this will be open. Okay, because in order to make this diode conduct, your voltage should be equal to the Zener's reverse voltage. Okay, and if you want to make this diode conduct, okay, so we need to apply the V input greater than this 3 volt, as well as if you want to make it conduct in forward bias, so there should be voltage of 0.7 volt. Okay, so if you want to make this diode conduct, we need at least 3.7 volt. Okay, so let us see what happens. So now, so when we increase the input, okay, up to 3 volt, okay, this is also open. Okay, this is also open, and and this is also open. Okay, this diode also open. So at 3 volts, this diode start conducting, and the voltage become fixed. Output voltage become 3 volts. Okay, so before 3 volts, if I draw my output, okay, in forward bias, okay, so up to 3 volt, okay, I'll get my V output equals to V input as it is. Okay, so up to 3 volt, I'll get this exactly equal to 3 volts. And once this voltage becomes 3 volt, input voltage becomes 3 volt, okay, this diode will start conducting, and the voltage will be fixed up to 3 volts. Okay, so if you anything beyond 3 volts input, output voltage is fixed to 3 volts. Okay, now what happens again when this is less than 0 volt? Again, you got V output equals to V input, so you get same thing here. So you get same input like this. Okay, now see what happens when you reverse the cycle. Okay, that means now this part is positive and this part is negative. Okay, so when this part is positive, okay, this diode becomes forward bias. Okay, this is still the reverse bias. If you are applying more negative, this will be again reverse bias. Okay, because this will make plus, this is mine, this is already reverse bias, so this is also making reverse bias. So this diode will be always open. Now in forward bias, okay, when this is plus, this is minus, this diode will become forward bias, and the forward bias voltage is given 0.7. Okay, so as soon as the voltage of input reaches 0.7, after that this diode become can be we can treat as like a battery, and the voltage will be fixed 0.7 volt. Okay, across the diode. Okay, that means your V output become fixed. So whenever you have a negative cycle, okay, initially the voltage will follow input, and then this will become fixed up to 0.7, and then this will go like this. Okay, so this is your, this should be your uh, output wave. Okay, and this output wave is, I think, given as option C. Let me check. Okay, so this type of option 3 is given. So you have 3 volts, and then you have this 0.7 volts. So this is option 3. Okay, so option 3 is correct. Okay, so thank you very much.